Whew. Boy, it is hot. July 10th. Anyways, gotta get the cables. Gotta get the shift cable and the throttle cable. Gonna mount that up there, right? And the cables have to go just along the outside of that and then go into that bay and then go under this corner and come out that hole right there. And the trick is, there is this wooden wall right here with carpet on it that doesn't go all the way up, so there's an area on the top there, so it's not horrible, but it is in the way enough, so it's kind of making it tricky for me. I can't reach through that hole right there and get that cable. So what I'm going to do is, I've got this hunk of PVC pipe. What I noticed was that if I look through this hole, I can actually see the inside of the wall about here. So I think I can just put this in at this angle. Hold on. There we go. Alright, like that. Alright. And get back in here. Take a look in here. And there is the end of said pipe. So now all I gotta do is, hopefully that pipe diameter is large enough to accept the end of this cable. So I'll just feed the cable through. No, that end of the cable is too large to get into the ID of this plastic pipe, but it turns out I could just, by reaching underneath there and using this as a guide and to run my hand along and pull that along, I was able to get it close enough so I could be right in the ballpark here and then reach in and grab the cable and pull it out. So there's one. Oh, now I'm just gonna run this back in again and repeat the process for cable number 2. All right, got both cables coming out where I want them now. So now I think they recommend that you loop these cables around to make a loop and then hook them on, and then that's supposed to give you just the right amount of slack, I guess, for full range of motion on the motor when it's steering. Alright, so because I couldn't remember which cable was which, whether or not I decided to use the new cable on the throttle or did I use the new cable on the shift, I ended up, all I gotta do is pull up this lever, which is the warm-up lever, which when you pull this lever, it only moves the cable for the throttle. And by doing that, I was able to determine that the new cable is for shifting. I meant to say the new cable is for throttle, which means that I was just hooking it up to the wrong place. So the old cable is for the shifter, so the old cable has to go in first. So that's going to pass through here, and you loosen this nut, you move this thing out of the way to expose that pin. This has to get dropped over that pin, okay, like that. And we can just move this back into position to kind of keep it from falling off temporarily, and I'm going to have to tighten that self-locking nut. Alright, so right now it's in neutral on the engine, okay, and I just got to double check and make sure it's in neutral on the Mercontrol, and it is. So I've got to make some adjusting here. This part right here, this plastic piece, has to go in that lower hole, and you can see it's too far back. So the problem is, if I push the whole cable forward to get that into the hole, well then I'm going to be moving this linkage enough that it's going to start shifting into gear. I don't want that. Now the reason why this might not be in the correct position, even though this is an original cable, is maybe this original cable was being used on the throttle before and now I've switched it to switched it to being used as the shifting cable, or maybe this thing just moved, although this doesn't look like it's moved in a long time. So I have to go with the assumption that I just switched this from being originally for the throttle to now being for the shifter. So I am going to have to, I'm not going to be able to spin this around enough, so I'm going to have to move. I'm going to take the cable back out just so I can spin that around, because it's threaded. So by spinning that, I can move it up into position. Alright, so see, I moved that up quite a bit from the position it's in. You can see the shiny brass area there is where that was, and I had to move it way up here. But now, that slides over the pin when it's in neutral. So, we just temporarily stick that in position so it doesn't pop off. And I'm going to temporarily clamp this in position. Like so, just so it doesn't pop out. I'm going to get my assistant out here and we're going to do some tests. So you know what's funny? I just got done finishing adjusting the linkage, and the way I did that was I put it in neutral and I made sure that this freewheel's in neutral, and then you like those shoes? Anyways, and then when I put it in forward gear, that it goes fully into gear, it basically clicks in one direction because of the way the teeth are inside the drive unit there. And then it can't turn in the other direction, because if you try and turn it in that direction, it'll crank over the engine. So that's how you know it's in gear, right? So I was doing that, and it was like I kept having trouble, and I kept having to adjust it over and more a little bit. Finally, I just said, you know what, just for the heck of it, I'm going to put it right back where this was before I thought I needed to move it, and it's perfect. So it's in neutral right now, freewheeling. And then, oh, if you're wondering where my assistants are, yeah, they couldn't be torn away from their video games. So now if I pop that forward, that's now in forward gear, and if I click it this way, nothing. Okay, well, not quite there yet, I guess. Thought I had it. That's still in neutral though. Thought I clicked that forward. Oh, there it is. That should do it. So see, it clicks, but if I try and go backwards, it won't go. Then if I pull it back to neutral, that should be neutral. Spins free again. And then back to reverse. See? No, not quite. Doesn't seem like it's moving far enough. I have to adjust it a little bit more. Pain in the butt. Alright, so I managed to pull my cables through. Now, this pile of wires right here, I'm not the least bit concerned with at the moment. Something like this can be very daunting to the
amateur mechanic. Wiring issues. Some guys just have a knack for it. Some guys just don't. As luck would have it, I have a background in electronics, and I don't know if that helps. Probably does. But I've always had good luck with being able to figure out wiring messes like this. The reality is, all of this wiring you see right here, this is all boat wiring that can be left completely disconnected and unused for the purposes, as far as the purposes of starting and running the motor go. All of that, ignition, starting, all of that is confined to simply these wires here. The need for the battery to be hooked up, and then the need for this wiring, which I have my temporary setup on, which is an on-off rocker switch for ignition and a push to start button for the solenoid, which we're about to replace with the newly rebuilt Mercontrol stuff. What this is, this goes up to the gauges and a electrical panel for the boat up front, which has things like switches for the bilge pump, the running lights, and horn, things like that. Also, like I mentioned, the gauges, primarily the fuel gauge. Tachometer is one of those tachometers that runs off of a pulse, which we may not be able to use with this motor. I haven't gotten to that point yet. I'm not worried about that. When I go to actually tune this motor on the water, I'm going to be using a dwell tach analyzer type of system to get me a really accurate reading on the RPMs. The stuff you see on these cables, all of this here that we're looking at, okay, these are to send raw 12 volts direct from the battery and raw grounds direct from the battery to the circuits in the boat, the lighting, you know, everything I just talked about. So the important takeaway from all this is that for the time being, I can just get a lot of this wiring out of my way, and we could sort that mess later. I am going to definitely want to get it on board sooner than later, especially because I want to see whether or not these two wires right here run down into the bilge, to the bilge pump. So this is something I would like to have working sooner than later, just in case we have an issue and we need to pump water out of the bilge. And then the fuel tank, which is out of shot right now. So for those of you who haven't seen it yet, this is the fuel tank that was in the boat when I bought it. I don't know if it's original to the boat or if it was made by somebody afterwards. It appears to be made out of all aluminum. I don't think it's stainless. But it seems like a pretty nice tank, and it has a sending unit in the top, and it, you know, it looks like at some point it was maybe hooked up to the gauge at the front of the boat. So for the time being, we're going to run this off of the plastic tank, you know, a portable plastic tank. But eventually I probably am going to want to try and use this tank and hook it up so that we know, hook up the gauge so we know how much fuel is in there. Because this tower of power is a gas hog. So up underneath here, there are these loops, almost like barrel-shaped protrusions that are molded right into the fiberglass on the underside by the boat manufacturer. And a lot of the wiring is running through that. So that's actually, they're acting as hangers to support the wires. I didn't run the cables through because they've got to come out of this area here to go to the Mercontrol anyways. I do wish, in retrospect, I wish I had run the steering cable through those. The problem is the steering cable is not flexible enough for me to bend it all the way back and now run it through. In order for me to run it through those now, I would have to disconnect it at the helm and pull it out that way and feed it through those.
it's not really hanging too low. And I think what I can do is I could probably use some heavy duty zip ties to actually zip tie it up to those loops. So that's an example of one of these fiberglass loops I'm talking about that run along the bottom here. So I am going to take a minute, and these wires here these are the two battery cables, so they got to stay near the rear of the boat here. Where the battery goes in this boat I haven't figured out yet. When the seat's in place, it's right up against the back of this. This tray area here isn't wide enough to fit the battery in. So I think the battery's supposed to sit in this little cubby hole right over here. So the tank, which is currently unbolted, has to shift over that way a little bit, and I think the battery just fits in there. If that ends up being the case, I'm probably going to just take these battery cables and, yeah, I don't even need to back them out all the way, or do I? I could probably get them to squeeze through here, and I could reroute these cables so instead of coming out over here, they're coming out back inside there, and the cables would just go onto the battery right back there. For all my testing and everything, I'm going to have the battery out here temporarily hooked up. But this cable, which is the remainder of the cables coming from the motor ignition system and start system, this cable I can run through those loops up to the front towards the Mercontrol. I've got a lot more length than I need. In retrospect, I probably could have wired this directly into the new Mercontrol, into the rebuilt Mercontrol, without having to do the kind of setup that I did in the previous videos you guys have seen. But I actually thought this was going to be too short. It turns out this is plenty long enough. Alright, so I just ran that cable up through all the loops, including even one way up here, so that the cable now is making a turn and coming back, and look how much cable I have left. So I could have easily just stripped this cable back and put it directly into the Mercontrol, so that it would be one continuous cable from inside the Mercontrol all the way to where it plugs into the motor on the back. I didn't have to go through all of this that I did here. Oh well. So I'm just going to tuck that excess cable up, loop it up, and tuck it behind there when I'm done. You know, in my defense, the reason why I was concerned about this cable not being long enough after I cut it back to this point was because of how bad the condition of the insulation is. Even here, where I've got it temporarily wired up, there's pretty bad looking wiring here. So I am going to end up cutting this sheath back to good wire, and I don't know how far. You know, we'll end up figuring out how bad this corrosion has traveled up this cable. Alright, so I cut back the outer sheath of insulation. Only had to cut off about 3 inches, and looks like I'm going to be okay as far as this wiring goes. Oh, I spoke too soon. That gray one's got a yeah, it's still got issues. Alright, we're going to have to go back a little further. Alright, I don't feel so bad about leaving this wire, putting this auxiliary wire on now, because I was worried about the length of this wire, because I'm cutting back and finding out that this wire is pretty bad going in to the sheathing even further. I've already cut off this much more, and even though the wire may look good initially after cutting it back, if I bend the wire over itself, I'm seeing it split. So the insulation's very brittle. Here's a good example right here. You see this yellow wire? Way up here, doesn't look too bad. But back here, these are not cuts in the wire that happened accidentally. This is the wire insulation's just dry and brittle and splitting. So that's going to need to be cut back further. So far I've got these wires here, which ironically aren't being used right now. Got these all cut back to what looks like pretty decent wire. So I got to focus on these 3 wires right here, which are what I've been using during my jury rigging and testing. So looking at my setup here, I know that on the starter switch, because I have 2 wires on this side, that this is the side that the switch is being fed from.
So we got 12 volts basically coming in here, and when you press the switch, 12 volts goes out to here to this one single wire. So that tells me that this wire right here, this yellow wire right here, is the one that goes back to the solenoid. I've already confirmed that. If I go back on my wiring diagram, I can actually see that that yellow wire coming from the neutral interlock switch goes over to, it comes up here, right here, and goes right to one side of the solenoid. The other side of the solenoid is ground, so if 12 volts is applied to that yellow wire, it's going to cause the solenoid to conduct, pull the plunger down, and send power to the starter. So I can cut this off now because I know that it's what it is for sure. And I could see that wire is bad all the way back here. Alright, so on the other side of the starter switch, I've got two wires. One is coming from the switch that I installed to turn the ignition on, and the other one goes to this wire here. So the fact that I've got this switch going to one wire coming up here tells me that this is where the 12 volts is being fed to the starter switch when this switch is in the on position, which means that this wire right here must be the always 12 volt line, which appears to be a white wire. Yeah, the white wire is going to A on the ignition switch. It runs over here to the switch box, but it goes to a connection on the switch box that also has this big red wire attached to it, which if we follow that red wire, it actually goes right to the well, it actually goes to that side of the solenoid, which means it actually goes to the battery. It goes to this big thick red wire going to the battery. So this is the always 12 volt line. This is the line. This is the line that always has 12 volts on it if the battery cable is hooked up to the battery. That leaves this wire, which when this ignition switch that I installed is on, 12 volts is sent down this wire, down this red wire right here. So this is probably the main power to the ignition switch box, and that goes over to terminal, hold on a second, it's the red wire. I might have had this backwards. Looks like this might be this heavy thick, that makes sense too, makes more sense that this heavy thicker wire, it's a heavier gauge than the rest. This is probably the always 12 volt line. So the way I had this wired, as long as I had the battery hooked up, there was always 12 volts going to the solenoid or the switch. So I could so I could crank. I remember now. I wanted to be able to crank the engine without the ignition on, to like if I had the plugs out and I wanted to basically just clear the cylinders. That's why. So this heavy red wire is your always 12 volt, which means this white wire is the 12 volt when this has 12 volts on it when the ignition switch is in the on position. So it's kind of hard. I thought that it was common to the red, but it's kind of hard. There's kind of a mess here on this photocopy. You can't really see what's what. But I'm sure if I open up the motor, that's what's going to be evident to me there. This wire actually looks overheated, damaged, but oddly enough, this insulation on this one is in much better shape than the rest of the wiring. Alright, I just double checked my color code here for the rewiring I did on the Mercontrol. I did use red for red, so I'm going to use this is going to be the 12 volt feed. I am a little concerned that the gauge of this wire is small compared to this gauge. We'll see if that'll be a problem or not. This is the white wire that's going to be when the ignition key is on, 12 volts. This is going to be connected to this when the key is in the on position or run position. So the 12 volts will be fed through this white wire back to the ignition switch module. This yellow wire here goes to the solenoid, so when the switch is rotated to the crank position, this 12 volts will be being fed to here and here simultaneously for ignition and crank. And I already verified that. And I also verified the neutral safety switch is working correctly. So if the boat is in gear and you go to crank the engine, it will not crank. Because that switch inside the Mercontrol is in series with this circuit. And then this orange wire right here, I forgot what color it was originally in the wiring diagram, but I ended up using the orange wire for the choke solenoid. So this will be connected to this when either the choke button on the top is pressed or the key switch is pushed in, as long as the ignition is in the on position, to send 12 volts to the solenoid that works the choke shutters on the carburetors. Well, that's it, pretty much done. Only using 4 wires. I ended up, my original plan was to use these butt crimp connectors and heat shrink tubing each one of them like this. Then on this very second one, I crimped the connector and realized I had forgotten to slide. It happens. Forgot to slide the piece of heat shrink tubing over the wire out of the way before I crimped it. So the only way to put heat shrink tubing on that second one at that point would have been to unfortunately cut out the connector and put another connector in, but then my wires were already cut to length, so then I'd have to redo the lengths, you know. And then I hit the heat gun on this heat shrink tubing, and I realized that the heat shrink tubing that I have that's large enough to go over the butt connector, unfortunately doesn't shrink up to go over completely, to go and make a watertight seal on this small diameter wire. On this big wire it worked fine, but on these other wires it's not going to work anyway, so I decided I'm just going to forego heat shrink tubing those up. These other wires, for the time being, I can just leave them, because one of these is just going to be a ground wire that's not being used by the Mercontrol currently. The reason why the ground wire gets sent to the Mercontrol is for the tachometer outlet, and also on magneto ignitions. If the Mercontrol is being used on a motor with a magneto ignition system, there's a ability to ground out the magneto when you have the key in the off position, to completely kill the ignition when you shut it off. So that's not needed. And then one other wire is the tach pulse wire. Sends the pulse from the switch box to the tachometer. Again, we haven't, like I mentioned earlier, haven't decided yet whether or not I'm going to be able to even use that. So not going to worry about that. I don't remember what the third wire is. I know what that's what these 2 wires are, ground and this. And these, I don't remember what these are. I mean, obviously one of them's the ground, one of them's the tach. I don't remember what this other wire is. And oddly enough, on the call-out diagram that I had there is no orange wire in the motor wiring harness, even though obviously there was one for something, because it's right here. Alright, so now I'm just gonna clean this up a little bit and tape this mess up. And here's the semi-finished product. I left the wires that I'm not using, I just left them out rather than tape it all up, because my thinking was at some point down the road I'm going to probably want to maybe explore the idea of using the tachometer wiring and running it, you know, I might just run a separate wire, quite frankly. I might run a separate wire from this point up to the dashboard to a tachometer and not even bother going through the Mercontrol at all. I haven't decided yet, but I know if I tape all of this up and this is all hidden, I'm going to forget that I didn't splice these wires together anywhere, and I might drive myself crazy wondering why I've got the Mercontrol apart and can't get a signal or continuity from the motor to the Mercontrol. So this way, if I look underneath there, I'll be able to just go, oh, well, yeah, that's why. Or, consequently, if I, like I said, if I don't want to use the wiring in the Mercontrol for the tachometer, I can just take the ground and whichever one of these wires is used for the pulse for the tachometer and run a separate wire from here right up under the dashboard to a tachometer.